Hey class, Mr. Modin here with an example video to help you with arc length and sector area using radians as opposed to degrees. Much of the format of or the approach to these problems are the same as if they were in degrees. You just have to know, which is less common sense, that a full circle is not 360 but rather 2 pi. So if you recall, this fact is useful for converting radians to degrees, and this fact spawns, or rather comes from, depending on how you look at it, the fact that 360 degrees, a full rotation, is equivalent to 2 pi radians. So we would typically set up a proportion. The question here, which is not written down, would say, what is the length of this arc? How long is it from this point along the circle to that point over there? So to answer that question, we need to set up a proportion, which is going to say that the angle that creates that arc, which is pi over 3 radians, so pi over 3, we're going to find the length corresponding to that. So in a proportion, you want to have part to whole. So part of the rotation is pi over 3. Well, that's relevant or meaningful relative to a full rotation, which again we typically call 360, but according to this fact, we're going to instead call 2 pi. And before I write the rest of the fraction, I'm going to note that these pi's will cancel, leaving me with 1/3 and just 2 on bottom. So that's going to be a useful technique to help simplify this. And my other part of the proportion is also part to whole. That's going to be this length, which is unknown, so let's call it x, and the full length all the way around a circle, which just like in degree problems with arc length is called the circumference. So that's 2 pi times the radius, formula you have to know, which is 2 pi times 13 in this case. So go ahead and cross multiply to see if we can get this proportion solved. This cross right here will give me 2x, and the other cross will give me, let's see, this is 1/3 times 2 pi times 13. Dividing both sides by 2, so notice I didn't actually simplify anything here, I just literally wrote down everything that was there. 1/3 times all this business. So dividing both sides by 2 gives me, let's see, 1/3 times pi, it's the same as pi over 3, times 13, which is 13 pi over 3. And the shortcut that I mentioned in class that several of you recognize was that, well, the two numbers you're given are 13 and pi over 3, and at this step the cancellation seems to suggest that you simply multiply those two numbers together. And the answer to that recognition is great job, because if you can find a shortcut, in this case the fact that the arc length, so arc length is equal to the angle in radians times your radius. So it's a useful technique to help you avoid some of this procedure if you find it too cumbersome. So if you recognize that shortcut, great. Probably aren't even watching this video because you know how to do it. But from here on out, if you would like to use that shortcut, by all means do so, recognizing that it comes from this proportion. Let's look at a similar problem, this time in the context of sector area as opposed to arc length. So this problem here didn't have any units, but let's say this was, I don't know, inches or something. Then this would also be in inches because this is a length, right? How long is it from here to here? So let's look at the sector area problem. So here we're looking for a space, right? A two-dimensional space. So let's say this is inches again. Our question is, what is the square inches, the area of this sector? So as ever, we're going to set up a proportion. The angle is 5 pi over 4. The full rotation is 2 pi. Once again, the pi's cancel. The area of the sector is unknown. And the area of a full rotation, which would be the area of the whole circle, again, prior knowledge tells me that that is the area of a circle, which is pi times radius squared. The radius in this case is 12. So pi times radius squared, or pi r squared. So cross multiplying again, this will give me 2x. This is actually 144 pi. And if I multiply that times 5 and divide by 4, that'll give me the other cross. So notice that I'm leaving the pi out, simply adding that to my calculation. So 144 times 5 divided by 4 gives me 180 pi. You could also accomplish this by 144 times 5/4, that's the same thing, just to clarify. So if 2x is 180 pi, then x is 90 pi. And if this is inches for our length, then this is going to be square inches for our area. And we did the squaring right there, you can see. And there you go, the exact sector area and the exact arc length directly from the problems. There is an actual shortcut here, so the last one had a nice cute little formula, which is arc length equals radius times angle. There's a similar formula for area if you'd like to know it. And that formula is this right here. Again, you can always do it with a proportion, which honestly I prefer because more formulas to remember. The area of a sector would be 1/2 radius squared times the angle. Again, this only works if the angle is in radians. That was also true for this formula right here. This has to be in radians. So, arc length and sector area. Hope this helps.